Hi, everybody. My name is Mary Grygleski. I'm a developer advocate at IBM, and I'm with the Java developer advocacy team. All of my teammates, there are four of us, Pratik, Billy, Sebastian, they already did their presentation earlier today. So if you missed it, I guess we can look up the recording later. So without further ado, thank you very much for coming to my talk. It is late in the day. I'm in Chicago, so U.S. Central Daytime. So I'll start the talk. I'm on my team. I'm responsible for doing things that are related to reactive. So as such, reactive is it's still a word of a lot of cause. I think it's just making people wonder what it is. I mean, there are groups of people who are working on things that are, quite deep into it, but they're also at the same time, a lot of us too are still probably churning out code, for the current production systems in some legacy systems. So kind of curious about reactive. So was I. Actually, before coming to IBM, I was also been very curious about reactive, and so I got a chance to work on this, and I'm kind of excited too because it is, as such, is a pretty exciting field that promises a lot. So let's take a look. Right now, too, I only get 20 minutes or so. So this is actually, it turns out to be a lightning talk of what I have done with this, which would have been a normal 45 minutes talk. But this one will be shorter, so I won't be able to get into a lot of the details. But as such, too, if you were at a session earlier with Josh, and actually he spent a lot of time talking about Spring Reactor and also RSocket. So that kind of helped me. And if you had been there, this probably will give you just go back a little bit to some details. So without further ado, sorry, I'm kind of taking a bit too long to talk about this. So let me kind of quickly then go through the reactive concepts again. So essentially, when we talk about reactive, we, in general, deal with different aspects of it. So reactive programming is really the programming on a module, on a component level. You're dealing with programs that are written using a functional style. And then reactive systems actually brings it to another level up. And as such, too, when we're dealing with systems nowadays, we have many components. And that's actually is the power of reactive systems. It's able to tie together a system that's full of components and pieces to it that are all isolated in time and space. And as such, too, the way, the purpose of such is that it's essentially, there's also a specification, I should say, it comes out, it's called Reactive Manifesto. So Reactive Manifesto essentially has 4 tenets to it, which is responsiveness, elasticity, resiliency, and message driven. So I won't go into a lot of the details, but there are links to it in which you can look that up and then get more details into it. And then comes to the reactive streams, and which is the focus of my talk today. So reactive streams as such is a specification that actually deals with asynchronous processing and handling of non-blocking back pressure. And let's then go into it and take a look into that. But first of all, too, when we talk about reactive systems, right, there are many mechanisms of making systems to be more responsive, scalable, and resilient. So these are some of the mechanisms that, how do we achieve that? So essentially, for reactive systems, we're dealing with systems that are distributed, and we need to handle concurrency. And also, here too, I'm basically talking about concurrency versus parallel, because concurrency, you're dealing with tasks that actually, in fact, they are maybe in a single thread or inside a CPU, you can only process the task. Essentially, they make you think you are doing concurrently, but it's actually a task that's being processed one at a time, kind of like that. But whereas parallelism is parallel processing deals with the hardware level, you do need to have multiple processor. And basically each processor can have a thread and that handles it. And so a multiprocessor will enable the parallelism. And then when we get into a bit more to what makes it possible is really the event-driven style of architecture and message-driven way of doing things. And they're two separate things. For event-driven, is dealing with messages that are being emitted. It's like in a publish and subscribe scenario. The message comes out and it doesn't have a specific address telling it where to go to. It's basically up to the subscriber, the consumer that are interested in it, or some event that will actually make, to trigger something to happen. And so the subscriber will then do something about this data. Whereas for message driven, we're talking about messages that have a source and a destination, and they actually have and it knows where it is going to. There's an address. And then there's also asynchronous versus synchronous processing that we're talking about in reactive processing. So in reactive systems, very often it's actually always the case in which we're talking about asynchronous style of processing in which request goes out and it doesn't wait for anything to happen to come back. Whereas for synchronous processing, which is also like a traditional legacy way of doing things, is that when you look at our code, it's being modeled as such so that there's a set of data and some request comes in and then it gets processed. And then it basically during processing, the requester will wait for the result to come back. So that's synchronous. And then there's also non-blocking versus blocking IO on that level. So non-blocking is not actually the same as asynchronous too. Non-blocking, we're essentially talking about IO. So when input comes in, it doesn't really wait. It drops things off and then it goes on. Whereas for blocking, it's really input comes in and basically the input will go in and wait for the output to come back. And actually for reactive, I also got a question that I've been asked too. They're saying, I've got a question in which they're saying that if there are lots of processing, how does, the system scale up or down? And currently, if you think about it, yeah, we can add more hardware to it. But that's not the case for reactive way of doing things. And we're talking about reactive. It's also making use of some threads, but the threads are basically in the user space versus in kernel space. And essentially, in reactive way too, it doesn't spawn off more threads to handle your tasks because as such, the kernel will process your let's say a Java application, you need some work to be done, so a thread spawns off. And the thread will then run essentially on the user space, but when it gets processed, it gets context switch over to the kernel. So the kernel will then process, process whatever you're doing, and then basically we'll switch back to your user space and give the results back or whatever it is back. So you can see if we have like too many threads, then it will become like very busy. It makes your code very busy. So reactive is basically making use of messaging inside your user space, so it doesn't need to actually sponsor up more threads to handle processing. So that's that. And I'll go to the next slide. Okay, and also giving a bit of a programming basics too. When we go back to reactive programming, just want to explain reactive systems in a kind of basic, kind of in a timeline. So if you look into it, I'm using Rx marbles to explain. So essentially, too, the top line in here is basically a stream that comes down, and there's no data in this case. And the second case is that there are data coming in, and it goes 1, 2, 3, and then basically there's like a perpendicular line in here. It basically means that your stream has terminated, it's finished processing. The third one in here, you can see too, is that there's an X, and essentially an error is also an event. So in some ways too, it is, in reactive programming is that it is basically you're treating the data error event as a first-class citizen, just like any other event that happens. And then the bottom one here is that in the timeline, data is being processed, and this one indicates a stream that's open. It keeps like receiving data. And also, this is an example, a basic example of how you do reactive programming. So over here is that if you look, I'm using a code from RxJava. So an observable essentially is basically is your data, represent your data stream. So in this case, if in the code there, you see that it is reading in the stream of 1, 2, and 3. So if you look into the timeline, you see timeline, you have 1, 2, and 3. These represents, the marble represents each of them have carry some data. And then using an operator, it operates on the stream, and it basically, for example, here is a map operator. It does a transformation. So this is, this is a functional style. So basically, 2 is that it transforms the number, the variable that comes in. In this case, if it's 1, it will multiply then by 10. And so in this case, you see then it processes it takes in the stream, and it transforms each one of them. And essentially, too, within the same command line statement, you do the consumer will do a subscribe, and the subscribe will basically consumes the results. So the result, what you see in here, the output comes out as item 10, item 20, and item 30. So you can take a look too if you're interested. This rxmarbles.com has a lot of examples of many different kinds of operators that helps you in your reactive programming. Okay, and also then talking a little further then about streams and giving you some fundamentals. Essentially, we're dealing with data that flows in streams, and the model we're using is really producer and consumer. So in this case, we're looking at producer coming in, and basically it flows down the stream, and there's some intermediate processing on a certain stage, and then it keeps going, and the next stage and next stage is, and eventually too is that your data will flow from a producer to the consumer, and that's the beauty too of doing reactive streams, because then it will mean that as long as the reactive streams implementation conforms to the reactive stream specification, you can essentially mix and match different types of library that are handling streams, because each of these streams, they are independently operated, even within it, your producer and consumer, for example. So you can basically chain together many kind of streams that are from different, constructs too. So. And here too, one thing to note is that for stream processing, we have what we call like push stream, and also like actually I should say a push model versus a pull model. So push is essentially upstream will pushes the data to the downstream. But the pull is really downstream will pulls the data from the upstream. And by this, the upstream is referring to the producer, and the downstream is the consumer. That's what I would look at. And let's take a look. So from upstream, we have a producer that emits data, and from there, it then sends, without being asked explicitly, to whatever consumer that has subscribed to the data. It will get sent over there. So that's push. Whereas for pull, it's downstream is initiates and then pulls from the upstream. So over here is a consumer. It needs something. So it needs data and it initiates. Essentially, it's doing a pull. In code form, it means a subscribe. So you do a subscribe. It's basically initiate. So it then like pulls data. So when the producer knows that somebody is needing it, then basically then it will emit data, and that will then travel downstream to the consumer. Okay. Okay, so next then, I apologize too, it's a little bit maybe incoherent today, but it's my first time doing an online presentation like this. So anyway, so I'm now moving into the next part, which is I'll talk a bit then about reactive streams, a little more, this specification. So it comes out from Java 9. It's essentially the flow as part of JDK, the flow API. And so this is essentially the org.reactive streams is the package name. And reactive streams is only a specification, and it doesn't have any implementation to it. So essentially, in ordinary, your application level, you probably do not want to deal with these reactive streams directly. Now, as such, there are only actually 4 interfaces in this specification. So it sounds simple, but as such, if you understand streams, it's actually the 4 interfaces can become quite a challenge too. So as such, then the suggestion is that you don't want to implement your reactive streams, and then you'll be wanting to use like service provider to do it. So it essentially it's meant to be for SPI, service provider interface. But it does come with the TCK, so the test compatibility kit, so to kind of verify that it conforms to the standard. And the good thing about this reactive streams is that it encourages interoperability. So as you can see, you have different streams that they kind of flow, and you can have different constructs. You know, you can have a Spring Reactor portion of your system, a flow that often you go into like Vert.x, and you actually can hook all of them up in that way, your application in that way. So over here, you can take a look to their, essentially, these are the major players right now. These are all, by the way, all open source projects too. So you have, I purposefully grouped together Spring Reactor and the essentially RxJava, the Reactive Extension, which actually originated from Microsoft, and then Netflix ported it to RxJava. I put them together is because it's essentially the same engineering team that worked on implementing the reactive streams. And then the next one will be Vert.x, and that's Eclipse Foundation project. And then Akka streams too, and comes from Lightbend and what used to be called TypeSafe, TypeSafe, yeah. And then we also too have MicroProfile too. Now MicroProfile is also an Eclipse project too, and that also they started supporting the reactive streams, the 1.1 specification since last July. And then another one which is quite interesting is the Reactive Socket, which actually now is part of the Reactive it's actually, I should say, from the Reactive Foundation that's where it's basically being focused on. The RSocket is on there, and and I'll talk a little in my next set of slides. So again, let me go back a little bit. So this is the what I mentioned earlier about the Reactive Streams API. So essentially, there are only 4 interfaces. You see that there's a publisher. So the publisher is essentially has a subscribe call, and then we have subscriber interface, and that essentially has the on subscribe and on next, on error, and on complete. So these two too, like you can't just have publisher and subscriber in a reactive streams type of stream operation because, because the thing is that we will also need the processor because that's responsible for processing between the publisher and the subscriber. And essentially, there's also a subscription. Essentially, is keeping track of the subscription that the subscriber is having right now. Okay, so then let me kind of go a little bit into each one of them quickly. So Spring Reactor came out from a Pivotal, but now it's actually VMware. So it has a Reactor core, and they also handle, they also actually, it's called the library, it's called WebFlux. And what WebFlux is really, what it is essentially is Flux is their way of handling multi-streams, is Flux. So from 0 to n items, that those streams are handled by Flux. And then if it's 0 to 1, that's called a mono. And that's how they're being like designed as. And if you have gone to Josh Long the talk earlier, he has actually example of how Spring Reactor is now has a tight integration to, or I shouldn't say like tight, but they actually interplace very well with the RSocket right now. So that's something new in there. And now then I also bring in Reactive Extensions, RxJava. Essentially, it's an API for asynchronous programming with observable streams, and this is the link to it. Essentially, to Reactive Extensions, it's basically version 1, RxJava 1 has what it's called observable, and that one doesn't have backpressure support. And then RxJava 2 is actually now called Flowables, and that actually has backpressure support. And by the way, all of this too, Spring Reactor also has backpressure support as well. Oops, sorry, not sure how I got into there. Okay, so now I also then another popular framework is becoming actually quite popular because of its quite easy and straightforward direct use. It's called Vert.x, and it's a reactive framework. It makes use of a verticals model, which is similar to the actor model. Essentially it has an event bus, the Vert.x event bus. It has its Vert.x runtime. So the event bus essentially is the one that kind of handles all of the requests that comes in, and that's how it is actually the core mechanism of enabling the reactive mechanism in there. And also, too, a note to point out is that Vert.x is also the framework that's being used by Quarkus, which is a Red Hat, a new library that comes out of Red Hat about a year ago. So that's actually the reactive engine behind Quarkus as well. So I'd like to point that out. And another implementation that's popular, which is actually Streams and come out of Lightbend. And over here too, I just have some highlights of it. It's basically Streams is quite kind of a rebellious nature because it says, well, I want to decouple from the Reactive Streams interface. So how it passes stream data, between individual operators, it's actually quite interesting. So something that to keep a note of. And basically, the API also is quite minimal and consistent too. And they basically advertise themselves like being explicitness over magic. So what you see is essentially what you get. And it's actually makes heavy use of composition. And also it provides tooling to handle all of the back pressure quite well too. Then now we also look into like microprofile. Again, microprofile is interesting because its focus is more about on microservices, and that's actually it's a strength too. And also too, a note to point out is that reactive streams are actually quite perfect to be utilized in a microservices architecture because of how similar in concepts it is between reactive streams and microservices, components being isolated in time and space kind of concept. So look into here is that they support like decoupling, temporal decoupling, and location transparency. Okay, so now there's also a RSocket, which I kind of mentioned earlier. So Reactive Socket is a binary protocol for use on byte stream transports. And there are 4 models. And the thing I'd like to point out is that you can have RSocket that has carry a request and a response. You can have fire and forget, and then request and a stream. And also what is interesting is it's a bidirectional. So you basically can keep the socket open too, and data can travel like in bidirectional. So that's a kind of a strong point about them. And the one thing I like to point out, this one I borrow from the Spring Run platform like slide, is about Reactive Foundation and the RSocket, which I mentioned earlier. So these are the companies, Reactive Foundation, that are supported by Netlify, Facebook, Lightbend, Alibaba, Pivotal, which is VMware now, and vLingo. So essentially, a quick note is that RSocket is a layer 5 and 6 communication protocol that's based on reactive streams. And it's promising to be very, very fast. And also the back pressure flow control is actually quite sophisticated as well. So yeah, please take a look into it when you get a chance. And, okay. And some additional info too about a particular specification, which isn't part of the reactive streams, is the OSGI library that has a push stream specification, R7. But this one is actually a push stream that also like makes use of their OSGI, the promises as well. And there's no dependency on the rest of the OSGI specification and framework, I guess, except for the OSGI promise. So yeah, if you're interested too, you can also check them out. They're a very pure push kind of stream processing model. And also, let me then point out too quickly is that the reactive streams, comparing to, if you look into reactive streams, the 4 interfaces, how it maps to the push stream too. You have publisher maps to push event source, subscriber to push event consumer, and the subscription to auto-closable, and processor to push stream. So, okay, so let me see. I think I not sure if I have enough time. I wanted to just quickly show a use case of using a CSV file watcher. It's basically
you have about 2 minutes.
Oh, 2 minutes. Okay. I guess then I may not have enough time to be kind of indicating, but I may just quickly let me see if I can switch. But I do need to stop my share, and then I have to. Okay. Oh. Okay. Let me. Okay. Okay. Sorry, it took a minute. So this actually is. I was going to quickly show very quickly show this sample that I have, and it's basically making use of Reactive Streams. So, but the quick thing to point out is that essentially over here is a sample case in which it watches for file changes inside a directory. So in my case, I actually quickly look at this. This is my configuration in here. So it basically files in the /temp/data directory. So if you go back over here, I just wanted to quickly point out, if I have time, it's basically the flow. So you can take a look into the flow. That's how we start, right? The flow is basically it takes a flat map and it concat, from a path from your directory. And another thing I wanted to point out is okay, sorry. Let me take a look. Okay, and the source in here. So this is the source file that basically, if there are any new files that are of this path, then it is basically it will read from it in this case. And basically, sorry. Okay, the flow. Here. So this is the thing. This is kind of interest is that if there are new files, and basically this directory changes source is already basically implements the Java NIO, the non-blocking IO watch service. So basically, this is where it is watching for what is going on in your directory. So let me then quickly show it to you to run it. If I have 1 more minute. And then I do need to bring my.
Well, you don't have another minute. We're at the end, but we're also going into a break. So I'll give you a minute. Give you 1 minute.
Thank you, Matt. Yeah, sorry. Yeah. Okay. But I do, and I apologize right now because I do need to search for my. Actually, I don't need to. But let me. I just have to bring my browser back into here. Okay. And that's that. Sorry. Okay. So I just want to. So we see that it is running. Is 8080. So you can see that over here, right? So this is running. So what I'll do is that I'll drop a file, which I already have.
We just see your ID. We don't see another screen.
Oh, you don't. Oh, you see my ID. Wait. So you do you see my Oh, I'm sorry. I think I wasn't sharing it. I have to share my screen, I believe. I'm sorry. Why is it not? No. I'm not sure how I can get my screen. Okay. Actually, this is. Can you see now?
Yep.
Okay. So basically, I'll just drop a file. I'll just drop a file into there. So basically, this is my program. Why is it not? Okay. So what I did was I just now drop a file into the /temp/data directory. So once it's received, then it basically comes back and immediately it will read it and also then tells you to like the data that's contained inside it. So yeah, so essentially that's just a simple example to illustrate that. So Okay.
Cool.
So yeah, all right. So I think I'm over time already. So
well, do you have any final slides you want to show? Because I can ask you one of the questions that was posed in Slack.
Oh, sure. Yeah. I do have to go back to my screen. You're right, and I apologize. Okay.
That's all right. That's the beauty of presenting right before a break.
Yeah, that's true. Okay. Yes, actually, it's perfect. It's my last slide. So this is just how you can contact me and IBM Cloud and all these resource connection, link to where you can find some resources, in general. And this one is actually a Reactive Streams resources to all of the links are in here too. So, and I can make this available too.
Great.
And then, sorry, just one more thing is I'll be running a Reactive Java podcast mini series in coming this summer. I'm already doing some recording, so please follow me Twitter handle. And then another thing is please visit callforcode.org, and this is in the spirit of fighting the COVID-19. IBM has this Call for Code challenge, so folks can sign in and join the hackathon for that. So callforcode.org, and that's all I have. Thank you.
Right. So the one question I have for you, thank you very much. That was excellent.
Thank you.
What is the common use case for Reactive Streams? Sounds like maybe it fits where something like ActiveMQ filled the gap before for guaranteed messaging.
That part is true. That will be like message queue is definitely that one. But I always like to tell folks is that what would be really neat is doing IoT. If you imagine like a big project, you're collecting some data that's streaming in from many locations. Let's say if you run a farm, you have many locations, and you need to collect some data from your farm. You have 2,000 acre. You install these devices. They all data maybe gets collected, maybe like rainfall or something, and water, whatever. And you can actually Reactive Streams would be like a very perfect use case for that, because then it handles data coming in streaming fashion. They all come in at the same time on different times and asynchronous, and it's very event driven. So that would be a really good case.
Cool.
Yep.
Well, thank you so much for speaking tonight, and I hope you have an excellent evening.
Thank you so much, Matt, and thank you everybody for watching. Bye.
Bye-bye, Mary.
Bye-bye.